The Minitab output shown below has obtained by using paired data consisting of weights in pounds of 26 cars and their highway fuel consumption amounts in miles per gallon. Along with the paired sample data, Minitab was also given a car weight of 3,500 pounds to be used for predicting the highway fuel consumption amount. Use the information provided in the display to determine the value of the linear correlation coefficient. Be careful to correctly identify the sign of the correlation coefficient. Given that there are 26 pairs of data, is there sufficient evidence to support a claim of linear correlation between the weights of cars and their highway fuel consumption amounts? So let's first take a look at the Minitab display. So I'm going to go ahead and click on that here. So if we take a look here at the top, here's the regression equation. Here's the highway. You have 50.1 minus 0.00517 weight. So this negative 0.00517 represents the slope, and it's a negative, and that is the y-intercept. And then over here you can see what our values are. Here we have the value of s, we have r squared, and this is the adjusted value. And we scroll down here, you can see here is the prediction interval and the confidence interval. So I want to come back up to here where it says r squared, which is equal to 64.4%. What we want to do is we want to first change this to a decimal. So if we move this over twice, that's going to give us 0.644. Another way of doing that is just saying, okay, since it's a percent, what we want to do is just take the value of 64.4 and then divide that by 100, and that gives us 0.644. Now we want to find the value of r. So since this is r squared, we need to take the square root of this number. So we're going to take the square root of 0.644. And then that's going to give us 0.82496. They want us to round this to 3 decimal places. So recall that since our slope is negative, this has to be a negative value. So technically, now rounding this to 3 decimal places is going to be negative 0.802. So let's go ahead and put that answer in. So negative 0.802. And there's our result. Now we need to determine, is there sufficient evidence to support the claim of the linear correlation? So we need to use this number here, and then we also have to look at the value of n. Well, n represents 26 pairs. So we need to go to our appendix, which is the critical values for the Pearson correlation coefficient. So if we scroll down here, okay, we have 25 and then we have 30, so we don't have the value of 26. But the value of 26 is closer to 25. Also, we weren't given the significance level. And once the significance level is not given, then we're going to use the 0.05. So looking at 0.05, and then we're going to use the value of 25, we're going to look at this value here, which is 0.9 or 0.396. So now we need to compare that to the linear correlation coefficient. So in order for us to do that, we need to take the absolute value of this negative 0.802. That becomes a positive value. And this 0.802 is bigger than the 0.396. Therefore, since it's larger than that, we can say that there is sufficient evidence to support the claim of a linear correlation between the weights of cars and their highway fuel consumption amounts. So we're going to go ahead and select yes, and there is our result.